This is Geometry, Chapter 7, Section 6, in which we will study similarity transformations. Now, previously we did congruence transformations back in Chapter 4, Section 7 there. Those were the ones that were flips and slides and rotations, twists, turns, those kinds of things. Remember the terminology we used. We started with a pre-image. That's what we called the original shape that we had. And we moved it to a new location, which we called the image. Now, back when we did this before, things were congruent. We didn't change size. We just moved it. These transformations that we're going to work with here have the same idea, but instead of maintaining the size, here you get different sizes. Think of a copier doing an enlargement or doing a reduction. That's what we're talking about. And the technical mathematics term for this is called a dilation. It's any kind of transformation that either enlarges, makes something bigger, or reduces, makes it smaller, by a set amount, and that set amount is called the scale factor. Okay. Now, something important to know is we have to have a fixed point that everything is being measured from. It's called the center of dilation. Using the copier example, typically when you put the paper down on the copier, the upper left point is the fixed point. So the upper left piece of, or a corner of the page, is your scale, or is your center of dilation. You tell the copier you want a copy that's 125% the size, then it expands everything from that point. Now, typically, when we talk about the scale factor, mathematicians like to use the letter K. If K is greater than 1, then we have an enlargement. You can think of that as if it's greater than 100%, so you're making the copy bigger. If K, this is a little bit of fancy notation, is between 0 and 1, then the dilation is called a reduction. Sometimes we'll use the word stretch and shrink. You can use either, as far as I'm concerned. Your book likes enlargement and reduction. Most people think of it as stretches and shrinks. Okay. Now, there's not a whole lot to these things. Most of what you're going to be doing is identifying scale factors. Occasionally, you're going to have to do something like use the distance formula to find the lengths so that you can find your scale factor. But the distance formula, by now, you're all experts at that, so that's not going to be a big crisis. So the question here for this one is to determine whether you have an enlargement or a reduction. And we're going from A, the original size over here, the pre-image, to B, the image after we did the transformation. Are we talking enlargement or reduction? Well, we're going from 6 to 4, so it's clearly a reduction. And then we need to find the scale factor. Well, the scale factor is the image size divided by the pre-image size. So 4 to 6, which reduces to 2/3. Now, something else I want to point out to you is if we were going the other direction, if B was the pre-image and A is the image, then we have an enlargement because we're going from a 4 to a 6. The scale factor will be the reciprocal. It'll be 6 over 4, which reduces to 3 over 2. Okay. Like I said, not a lot to these similarity transformations. You're mostly going to be dealing with trying to find scale factors. Occasionally you'll have to find how big the other side will be. If I told you this side was 7, you would have to figure this out. And you can do that with just straight proportions like we did before. So hopefully, if you had questions along the way, you wrote those down, bring them in, and we will see you in class.